The Earth is a small, wet rock spinning in the vast emptiness of space. What makes it special is a thin, invisible layer of gas, the atmosphere. Within it lies an even thinner shield, ozone, protecting us from the sun's most harmful ultraviolet rays. Without this shield, life as we know it would be impossible. Yet, we rarely think about it. The ozone layer silently absorbs dangerous radiation while we go about our lives. But this shield is fragile, vulnerable to the chemicals and gases we release. Our inventions, meant to improve life, can tear it apart, molecule by molecule. The story of the ozone layer is a story about us, our power to harm, and our responsibility to protect. The urgency is real. Climate change, melting ice caps, and rising oceans are happening now. The same activities that warm our planet also threaten our atmospheric shield. What we do to the climate, we do to the ozone, and to ourselves. Today we stand at a crossroads, more aware than ever of the damage we've caused. The question is not whether there's a problem, but what we're willing to do about it. Our atmosphere's fragility is a mirror, reflecting our choices and responsibilities. We have the power to alter the very chemistry of our sky. This is both a testament to our ingenuity and a warning of our hubris. The threats to our atmosphere are direct consequences of our actions. Our future depends on how we respond. The sky above us is both our shield and our challenge. In the late 1970s, scientists noticed a massive hole in the ozone layer above Antarctica. The culprit, chlorofluorocarbons, or CFCs, found in everyday products like refrigerators and spray cans. These chemicals drifted into the stratosphere, where sunlight broke them apart, releasing chlorine atoms that destroyed ozone at an alarming rate. Our conveniences were dismantling our planet's primary defense against solar radiation. The discovery sparked global alarm and, remarkably, swift international action. The threat transcended borders. A can of hairspray in Paris could damage ozone over the South Pole. Scientists sounded the alarm, policymakers listened, and the public demanded change. The result, the Montreal Protocol, signed in 1987, committing nations to phase out CFCs and other ozone-depleting substances. It's widely regarded as the most successful international environmental agreement in history. Political adversaries united to address a common threat. Industries innovated, consumers adapted, and the treaty became a commitment to real action. The Montreal Protocol proved that humanity can recognize a global crisis and work together to solve it. It's a powerful reminder: when we act together, we can achieve remarkable things. The ozone hole was a warning, but also a turning point. Our response showed the world what's possible when science and cooperation lead the way. The Montreal Protocol remains a model for tackling global challenges. It's proof that change is possible, if we choose it. The Montreal Protocol wasn't an instant fix. CFCs lingered in the stratosphere, continuing their damage for years. Healing the ozone layer was always going to be slow, like a deep wound closing over decades. For years, the Antarctic ozone hole reappeared each spring, a reminder of our past mistakes, but gradually, the data changed. By the early 2000s, ozone depletion slowed and harmful chemicals began to decline. The planet started to heal, thanks to our collective action. Today, the ozone layer is thicker than at its lowest point, and the Antarctic hole is smaller and less severe. If we stay the course, full recovery is possible within decades. This recovery is a testament to science-informed policy and global cooperation. But the healing isn't guaranteed. New threats and interconnected climate risks remain. The ozone layer's recovery is precious and fragile, requiring constant vigilance. Environmental victories must be protected, not taken for granted. As climate change accelerates, some scientists look to the ozone story for inspiration. What if we could do more than stop the damage? What if we could actively repair or enhance the atmosphere? Enter geoengineering. The idea of supplementing the ozone layer by injecting ozone or catalysts into the stratosphere. This represents a profound shift, intentionally altering the planet to counteract climate change. The concept is bold. If we broke the atmosphere, maybe we can fix it. An artificial ozone layer could act as a planetary thermostat, absorbing more solar energy and potentially cooling the planet. But this is no simple engineering problem. It's a global experiment with immense stakes. Are we ready to become caretakers and engineers of our own sky? To create an artificial ozone layer, we must understand ozone itself, a molecule of 3 oxygen atoms, highly reactive and unstable. In the stratosphere, ozone forms and breaks down naturally, driven by sunlight. Geoengineers propose several methods to enhance this process. One idea: use high-altitude drones or balloons to generate ozone directly in the stratosphere, using solar power and the oxygen already present. Another: inject catalysts that encourage ozone formation without triggering harmful side effects. These approaches require a deep understanding of stratospheric chemistry and years of careful research. The potential benefits? Accelerate ozone healing and increase solar energy absorption, cooling the planet, but the risks are significant. Introducing new chemicals could have unpredictable effects. Any intervention would need rigorous testing and global oversight. The goal: strengthen our shield and manage solar radiation, but only with extreme caution. The stakes couldn't be higher. Engineering our atmosphere is both tempting and dangerous. The climate system is complex. One change can trigger unexpected, even catastrophic consequences. History warns us. CFCs were once thought harmless, yet they tore a hole in the sky. Introducing new chemicals could disrupt natural cycles or shift weather patterns unpredictably. Once started, geoengineering could become a dependency. If stopped suddenly, the planet could face rapid, devastating warming. Before acting, we must weigh the risks, ethics, and the irreversible nature of such choices. Geoengineering isn't just a scientific challenge, it's a political minefield. If one nation deploys an artificial ozone layer, the effects could be global, sparking conflict over unintended consequences. Who controls the thermostat? Whose interests are served? Unlike banning chemicals, geoengineering means actively changing the planet. Reaching consensus will be incredibly difficult. The mere possibility of a technological fix could reduce the urgency to cut emissions, creating a dangerous moral hazard. The promise of a future solution could delay real action, making us more dependent on risky technology. Geoengineering is a gamble with global stakes. We face a slow-motion emergency. Climate change is outpacing our efforts to cut emissions. Geoengineering, like an artificial ozone layer, is both a sign of desperation and a testament to human innovation. Our greatest triumphs and mistakes come from this drive to solve problems. The Montreal Protocol proved we can act together and change course. The safest path remains a rapid transition to clean energy, addressing the root cause, not just the symptoms. We must approach geoengineering with humility, investing in research to understand risks before acting. The goal is knowledge, not an excuse for inaction. Our future depends on choices we make now, blending ambition with wisdom, power with restraint. The conversation about artificial ozone forces us to think globally and responsibly. Our survival may depend on it.